In the next example, we're going to find the area of a label on a can. This would be a surface area type of problem since it goes around the outside of the can, not the inside. So I'm going to use surface area, but I'm not going to use the entire surface area formula because the label does not touch the tops and the bottoms. So the formula for surface area was 2 pi r squared plus 2 pi r h. If we remember, this part right here was for the top and the bottom, the two circles. Pi r squareds are circles, there's two of them. That's for the top and bottom, so I don't need those two parts in this particular case. I'm just going to use the 2 pi r h. So the label size is going to be 2 pi r. R looks like 30 was the diameter, so half of that, 1.5, is going to be the radius. So 2 times pi times 1.5 times the height, which is 4.5. I multiply all that together, that will give me the area of that label. So I need 2 times 1.5 times 4.5. Those are the coefficients. Oops, I forgot to type the 4. Looks good. Okay, so this is 13.5 pi square inches, which would have 13.5 pi square inches, which would be approximately 13.5 times pi, which is 42.4 square inches. Alright, let's find the volume of this shape right here. This is a pyramid, but it's not the same pyramid we saw before. This pyramid has a triangular base instead of a rectangular one. So its volume is going to be 1/3 times the area of its base times the height. In this case, since the base is a triangle, we have 1/3 times the area of the base is 1/2 base times height. So 1/2, 19 times 17, times the height of this pyramid, 23. Let's go over to the calculator. We want 1/3, the fraction, just type it in with the division key, times 1/2 times 19 times 17 times 23. 1238.17 in centimeters cubed for volume. Right, part C. This is a cone. It's upside down, but it's still a cone. So the formula for the volume is 1/3 times the area of the circle, which is pi r squared. R is 5. 1/3 pi r squared times the height, which is 13. The exact figure would be 1/3 times pi times 25 times 13, or 25 times 13 is 325. So it's 325 thirds. Multiply the whole numbers together, put it over 1. 3 times 1 is 3. So the exact figure would be 325 thirds pi centimeters cubed. The approximate figure would be 325 thirds, so divide by 3, then multiply by pi. So 340.34 centimeters cubed. Alright, a couple composite volume shapes here. Let's find the volume of this shape. This is a pyramid on top of a box. So the pyramid part first. The pyramid is 1/3 times the area of the base. The area of the base is 20 by 20. So 20 times 20 times the height, 21, plus the volume of the box, 20 by 20 by 60, length times width times height. So altogether, we're going to have, let's see, we can simplify a little bit right here. 3 goes into 21 7 times. So 20 times 20 is 400 times 7 is 2,800. Plus 20 times 20 is 400 times 60 is 2,400. Oops, I'm 6D, not 6. So that should be 24,000. And add those up. We get 26,800 cubic feet. Let's look at the next one. This one is a cone sitting on top of a cylinder. So the equation for the volume will be first for the cone, 1/3 pi times radius squared. If the radius, or if the diameter is 24, the radius is 12. So 1/3 times 12 squared times the height for the cone portion, which is 16, plus the cylinder. The cylinder and the cone have the same circular piece, so we'll see that pi times 12 squared again. Pi r squared, pi times 12 squared. But the height is different. The height for the cylinder portion is 9. So the exact answer here would be 1/3 pi times 12 squared is 144 times 16 plus pi times 144 times 9. 144 times 16 is 2,304. I'm going to divide that by the 3 for the 1/3 here. This is 768 pi plus 144 times 9. 144 times 9 is 1,296 times pi. So if I add those up, 1296 plus 768, I've got 2,064 pi as the exact answer. I think I read that wrong. Yeah, 2,064, that was right. 2,064 pi cubic feet. And that's approximately, let's multiply that by pi. It's approximately 6,484.23 cubic feet. On the next page, we've got a few examples involving triangles. The measurements of the 3 angles of any triangle is 180 degrees. In example 14, this problem, we have a triangle that has 3 angles. All triangles have 3 angles. The measure of the second angle is twice as large as the first. The measure of the third is 20 more than that of the first. So let's make a list right here to give us the information of the first, second, and third angles. Alright, I'm told that the measure of the second is twice as large as the first. So if I say that the first angle is x, the measure of the second angle is twice as large, so it must be 2 times x. the measure of the third angle is 20 more than that of the first, so the first angle plus 20. So I've got a way of expressing all three of my angles. Put it together with what I know about triangles. The sum of the measures of the angles is 180. So the first angle, x, plus the second angle, which is 2x, plus the third angle, which is x plus 20, will equal 180. So I've written an equation here that we can solve. X plus 2x plus x, it's going to be 4x altogether, plus 20 equals 180. So if I subtract 20 from both sides, 4x equals 160. Divide by 4. X equals 40. Alright, so my answers here are going to be that the first angle, x, has a measurement of 40 degrees. The second angle was 2x, so it's going to have a measure of 80 degrees. And the third angle, x plus 20, is going to have a measure of 60 degrees. 40 plus 20 is 60. Objective 5, solving problems involving complementary and supplementary angles. Two angles are called complementary if their sum is 90 degrees, and they're called supplementary if their sum is 180 degrees. If the angle is called x and the two angles are complements, the other angle has to be 90 minus x, since their sum is going to be 90. If I knew that one of my angles was 30, and I knew they were complements, the other angle would have to be 60 to make them add to 90. If one angle is x, the angle supplement would have to be 180 minus x. So in the last example here, an angle's measure is 60 degrees more than that of its complement. What is the angle's measure? Okay, so I have angle and the angle's complement. Okay, an angle's measure is 60 degrees more than that of its complement. So let's let the angle be x. The complement is 90 minus x. Let's go about setting this up. The angle's measure is, that's an equals word, so the angle's measure is x, is 60 degrees more than. More than is an addition phrase, so 60 plus the measure of the complement, which is 90 minus x. So let's solve this equation. X equals 60 plus 90 is 150 minus x. Let's add x to both sides to get all of our x's on the same side. X plus x is 2x equals 150. If I divide by 2, I get x equals 150 divided by 2 is 75. That's going to tell me that the angle is 75 degrees and the complement, which is 90 minus x, is 15 degrees.